5, 4, 3, 2, 1.
All right, liftoff and the clock has started. Yes, sir, reading you loud and clear.
Is John Grunsfeld, astronaut and Associate Administrator for NASA's Science Mission Director at NASA Headquarters, Alan Stern, New Horizons Principal Investigator in the Southwest Research Institute in Boulder, Colorado, and Alice Bowman, Mission Operations Manager at Johns Hopkins Applied Physics Laboratory. Ladies and gentlemen, Pluto has never seen before. 3, 2, 1. And now we have remarks from Dr. John Grunsfeld.
It's been an incredible voyage. I know many of you the last few days have been participating, but what it all comes down to is an enormous team of people led by Alan Stern, the principal investigator, a big team here at the Johns Hopkins University Applied Physics Lab, Southwest Research, Ball Aerospace, University of Colorado, the list goes on and on, hundreds of scientists, engineers, technicians, people sewing blankets to be able to prepare this wonderful intrepid explorer, the first to visit Pluto and to fly on beyond into the Kuiper Belt. This is true exploration. I'm so glad you're all here to participate in it. And this, whoops, it disappeared. That view is just the first of many, many rewards that the team will get, especially since Pluto didn't turn out to be a relatively featureless planet with nitrogen foggy atmosphere, and we're scratching our heads, thinking, okay, what are we going to do with that? Pluto has turned out to be an extraordinarily complex and interesting world. Of course, it would be, but that was never a certainty. But now, for the very first time, we know that. And with that, for his first impressions, I'd like to turn it over to Alan Stern.
Thank you. 50 years ago today, the United States was embarking at the beginning of an era of exploration of the solar system that will live forever in history. 50 years ago today, the first spacecraft flew by Mars. It's called Mariner 4. And I think it's fitting that on that 50th anniversary, we complete the initial reconnaissance of the planets with the exploration of Pluto. A big team of people worked 15 years to do this. They worked under the gun for time. They broke records for low-cost outer planet exploration. They did some amazing feats, and we saw one of them just last weekend in terms of that mission operations rescue of this flyby that produces images just like the one that you saw, and many more that'll be raining to the ground beginning tomorrow. But stay tuned. Stay tuned, because our spacecraft is not in communication with the Earth. We've programmed it to be spending its time taking important data sets that it can only take today. And over the next period of about 12 or 13 hours, the spacecraft will continue to take that data, and then it will transmit a message back to the Earth for about 20 minutes at 9 p.m. Eastern Time, in which we'll find out how it's doing. Whether it survived the passage through the Pluto system, and hopefully it did, and we're counting on that. But there's a little bit of drama, because this is true exploration. New Horizons is flying into the unknown. And then, tomorrow morning, we should see the beginning of a 16-month data waterfall. You'll be seeing more and more about Pluto beginning tomorrow. But if we could put that image up, which is now the best image, it has a resolution of about 4 kilometers per pixel, which is approximately 1,000 times better than we could do, even with the biggest and baddest gun telescope, the Hubble Space Telescope, 3 billion miles away at Earth. New Horizons took that image yesterday, downlinked it to the ground. The bits in that image flew at the speed of light for 4.5 hours, received at NASA's Deep Space Network, transmitted here. The image was opened this morning. And how about a round of applause for that beautiful planet? The science team assembled at 5:45 this morning for a chance to see that best image of Pluto and to react to it and to have a little bit of a scientific discussion. And I think we're going to give you a peek into it if we can cue it up. Okay, so this image is oriented with Pluto's, with north to the top, and so the dark regions that you see are near Pluto's equator. The planet is about 1,500 miles across, to give you a scale. It's got a thin or a rarefied nitrogen atmosphere, which you can't see in this image because it's clear, just like looking through other tenuous atmospheres. But what you can see in this image, and it's possible for the folks behind the scenes to actually just make it a larger fraction of the screen. You'll be able to see it. You can see regions of various kinds of brightness, very dark regions near the equator, very bright regions just to the north of that, broad intermediate zone over the pole. And what we know is that on the surface we see the history of impacts. We see a history of surface activity in terms of some features that we might be able to identify as tectonic, indicating internal activity in the planet at some point in its past, or maybe even in its present. And what we also know is this is clearly a world where both geology and atmospheric climatology play a role, because Pluto has strong atmospheric cycles. It snows on the surface. The snows sublimate and go back into the atmosphere each 248-year orbit. Those snows have been observed to move around on the surface, seen from 3 billion miles away. We look at that image, and frankly, if you're a scientist like I am, you want to see all the supporting data. You want to see the topography that we'll get from stereo so that we can determine what's high and what's low. You want to see color data so that we can start to identify the different compositional units. You want to see the composition spectroscopy so that we can determine what those different areas are made from. You want to see the thermal maps so that we can understand are the brightest areas, the coldest areas, for example, where the snow has plated out, or is it some other story that Pluto is trying to tell us? You also want to see higher resolution images, and in fact, by tomorrow, we'll be able to show you imagery with 10 times the resolution of that image. And eventually, as the data continues to come to the ground, we'll have imagery that's better still. Dramatically better still, in fact. So there's a lot more to teach us with the data that's coming down, and we just couldn't be happier about the performance of the spacecraft, and frankly, about the performance of the Pluto system.